So I welcome Ola Zawalna-Geer, research fellow at the University of Exeter, that will present us the technical potential for the seawater air conditioning in the Channel area. So it's the presentation that we had this morning, but with more details, maybe. Okay. Ola, firstly, you are muted, and
Oh,
just just before you start, I see that Dan has a question for Theo.
okay.
Um, Dan, if you can ask your question. Okay, the question is, can we somehow farm the algae?
Um, so that would be so we do know algal farms do exist. So yeah, that would be the idea of possibly by remedying the water quality issues, you could farm the algae in one side of the facility, say, whilst improving your water quality, and then the water could then flow over into your kind of aquaculture species, and then that would give another product for an aquaculture facility. So they'd have the algal products, and then they'd also have their aquaculture species. Also, if they weren't going to sell it on, they could possibly use the farming of those algal species to then feed their aquaculture species. That would be another option. But yeah, in answer to it, yes, you could farm them.
Yeah, and you might want to look. I'm talking to Dan. You can look at the company Les Algues de l'île de Ré. I've been working for them 4 years ago, and
Okay.
they started to farm algae in the I don't know the name in English, but where we cultivate salt in French. Um, so they use that to like they fill up like a basin of water, natural basin of water, and they cultivate algae over there.
Okay. Would you be able to send me through the name of the company?
Yeah, I will send
After.
that. No
Thank you
problem.
very
No
much.
problem.
Thank you.
Thank you very much. And okay, Ola, I give you the scene.
Thank you. Can you see it?
Yeah.
Perfect. Perfect. I'm Ola Zawalna-Geer. Ola is short for Alexandra, so this is a little discrepancy on the slide. I'm the research fellow in Renewable Energy Group at the University of Exeter. And I'm going to talk today about the technical potential for seawater air conditioning SWAC in the Channel area. So seawater air conditioning, this is a little bit repeating slide on the left, the picture on the left, but I will just say, because I think it's important for this presentation, seawater air conditioning is eco-friendly alternative to conventional air conditioning. And as it was mentioned already, it exploits temperature difference between seawater and external air to cool or heat amenities. This last sentence is really important, because this is pretty much what I have been doing, and this is what I'm going to show you, this difference in temperature. SWAC reduces energy consumption, uses renewable source of energy, the seawater, and increases energy independence, which is really, really important in today's world. With all of those pros, really, why is it still so rare? And it is because SWAC technology is still very underrated and unproven in the temperate climate of the channel. And to make it more popular and accessible, a definition and analysis of the technical, environmental, and financial replicability is required. And this is something I am working on. Sorry for that. Talking about the SWAC potential, first of all, we need to look at the basic criteria for the SWAC consideration. And we need to have the access to the sea, obviously. There must be some cooling heating demand. And the place also may like to reduce the CO2 emission. On the left here, we can see the map. All of the yellow areas are eligible regions in the EuroSwac project. And all of the red dots are all of the places which I identified, which can be potential for SWAC system or to analyze SWAC potential. So we also categorized those locations and they obviously are being taken differently in accountants. So we have the tourist and leisure attractions, hotels, supermarkets, hospitals, research facilities, harbor facilities, and data centers. We have already demonstration sites, 2 demonstration sites in England, and it is the National Lobster Hatchery, which we just heard a presentation from in Newland, and also we have the Brixham Laboratory in Brixham. We also, the project is doing 3 case studies, one for big industrial site in the Normandy, one for the Oceanopolis, Ocean Discovery Park in Brest, and also Glacier Municipal Diatel right here. So to start even talking about any replicability of the SWAC system, we need to identify the main components which can be optimized in SWAC technology. And here I attempted to recognize all of them. So first of all, we have the SWAC maximal thermal power, which considers customer maximal cooling and heating demand. Also, what's the targeted delivered temperature, and finally, what's the energy saved versus SWAC peak capacity. Then very important is also intake day, which will then influence the whole pipe system. So at the pipe system, we're looking at the rate flow. Then rate flow will influence the pipe size. And then having the rate flow and the pipe size, we also can calculate head loss, which will go straight into influencing pumping system we are going to install for the SWAC system at the particular location. So pumping system will rely on calculation of the head loss and is defined by flow rate and manometric height. With the pumping system, there are 3 more components, and it's the location of the pump, where we're going to install it, type of the pump to be installed, and also the capacity. And finally, we're also looking at the heat exchange area, which will depend on the size of the SWAC, about the installation parameters, etc. But generally, we are looking at the difference of temperature more than 0.5 degrees Celsius. There are some environmental requirements for SWAC replication, and here we identified 3 most important. It's local bathymetry. Local bathymetry will have an effect on the intake depth, optimal intake length, but also during the installation of the whole SWAC system. Then we have the thermal gradient of the seawater, so how the temperature is changing with the depth. And then the surface, the air temperature. So those 2 last points is generally this difference temperature between the air temperature and the seawater temperature, which is really very important for optimizing the SWAC system. Then we also identified another 3 parameters, and there is a thermal discharge mixing zone, mandatory regulations, and environmental impact assessment. When it comes to the environmental parameters as well, we have another two partners on the project, and it's a University of Plymouth and NKE. NKE installed some monitoring equipment. So we have at the Brixton laboratory, so at one of our demonstration site, and all of the numbers from the monitoring go into the research, how the SWAC system can influence the waters, ambient waters. University of Plymouth also is doing the computational fluid dynamic modeling. So they are using the different speed of released water, and they are checking how it's mixing up with the water and how it can influence the ambient water. So closer to my work, this is the model, this is the framework of the model I have been using for checking the potential of the SWAC in the channel area. So as we can see, most of the boxes are already ticked. I'm not going to go too much in detail because I will be talking about it in the next slides. So first of all, I already mentioned how important is bathymetry. And here we can see that I collected a lot of data of the bathymetry in the channel area. This allowed me to create a really detailed map of bathymetry, which can be used for the whole channel, but also can be used at the individual locations. And having this bathymetry, then I collected the data of the sea water temperature at different depths. And I have also collected the data of the air temperature on the land. And here we have all of those maps, and we can see there is a different temperatures at 0, 3, 10 meters, 15 meters, 20, 30, and 50 meters depth. We're not going any further because we can see that at 75-meter depth, well, the channel is very, very shallow, so there is not much. So we will be focusing rather on those temperatures to up to 50 meters. We can see that there is no well-defined thermostratigraphy within the channel. Waters are mixed even to the depth of 50 meters by tides and currents in the channel. The temperature is not much colder than air temperature, so we cannot expect those very cold water, 5 degrees of Celsius, like we can expect in tropics. And we can also see that the colder water are definitely along the Atlantic coastlines. Then looking at the SWAC potential for cooling, so we can definitely see that there is some potential. So I was generally looking at the temperature when the difference of temperature between the air and the sea is at least 4 degrees of Celsius. And we can see that there is some potential. It's the potential in the south, Cornwall, Devon, even Dorset, and west coast of Brittany. Then the difference, the 4 degrees of at least 4 degrees of Celsius difference temperature, we can already see at the 15 meters, but it's more significant at 20, 30, 50 meters depth. Then I was looking also having those differences of temperature and the area identified where the SWAC has some kind of potential. I was looking in also SWAC capacity in those areas, and I did those maps for the whole channel. And here at above we have the annual cooling degree hours. So there are all of the hours over the year which were over 20 degrees of Celsius, because generally for cooling we are thinking about cooling buildings once the temperature starts at 20 degrees of Celsius. So we have all of those hours. We can see that in our eligible areas, there are not many hours needed for cooling. It's even more visible here on this map when I created a cooling capacity factor for SWAC, and we can see that in our eligible areas in the channel area, this capacity is less than 5%. However, we shouldn't discourage here to SWAC because, how I already mentioned, this is for the building when the outside temperature reaches 20 degrees of Celsius. But obviously, there are loads of facilities along the channel which demands much colder temperatures and the continuous cooling. It will be the research facilities, harbor facilities, data centers, etc. Then we are looking at the winter seawater temperatures, and the situation is very similar. So again, the water temperature is very similar to air temperature. The waters are mixed by tides and currents in the channel. There is no well-defined thermal stratigraphy within the channel. What's interesting on those maps is that you can see almost straight away that all of the water and the temperature is influenced by the continental masses, continental temperatures, and we can see that the cold is coming from the east. And I would like to point here the water, because at the shallower depths coming from the east, we have temperatures of lower temperature, and from the west we have the waters which were warmed by the Gulf Stream. So they are kind of the Gulf Stream waters are encompassed by the cold waters from the east, which can have some potential for the cooling in those areas. Then we are going to look at the SWAC potential for heating, and we identified few areas. Again, I took the temperatures which it's difference at least 4 degrees of Celsius, and we identified those. I would like to point here straight away that those shallower waters have better potential. The temperature difference is much bigger than in any other places. And also, I've created the annual heating degree hour map, and we can see again that this area here has a great potential for the SWAC heating, and it is also repeated on this SWAC heating capacity factors. And we can see that this area for the heating, it's up to 50%. What's interesting also is this area here, which obviously needs more heating. So here we would investigate the SWAC potential as well. Then looking at the identified areas for the SWAC, for the SWAC, I was also looking at the particular places along the coastline. And what is really interesting is that in the winter we can see that the temperature pretty much doesn't change, doesn't matter what depth it is. So obviously, if we're looking at the SWAC system only for the heating, we are looking for shallow waters. We don't have to go any deeper, which will cut the cost. We also can see that in the winter, generally the temperatures of water temperatures are higher than the air temperatures. So this is obviously the potential for the heating. And in the summer, we are looking at the temperatures at the water temperatures at the 20 to 50 meters, because then there is a difference, and those the waters at this depth are definitely a little bit cooler than daily temperatures. But then we have to also think about, we can talk only about the heating, or we can talk only about the cooling. But to cut the cost of the SWAC, we would like to use the SWAC throughout the whole year. And here are the maps. I already mentioned that it doesn't matter what depth we are going in the winter, because the water temperature is exactly the same. But it's different for the summer, and for summer, the optimum temperature was at 20 meters and 30 meters. So obviously, those temperatures would be the best for the SWAC throughout the whole year. Then I also create those maps because I think it's quite important and it's quite interesting for the SWAC potential here in the channel. So here the map with the red dots, we have the energy for current heating and cooling and how it looks along the coast. And then with the SWAC, so I took the what is used, electricity and gas for cooling, for general, for all of those locations. I estimated that around 40% is used, electricity is used for cooling and heating, and around 90% is used of gas is used for heating. So based on those estimates, we can see that we can save quite a lot of energy with the SWAC, 50 to 60% in England and 10 to 30% in France. And then also this allowed me to calculate the... excuse me, can you please mute?
I've muted him.
Okay.
Please continue. Sorry for that.
It's all right. This allowed me actually to calculate the carbon footprint reduction, and we can see that with the SWAC we can reduce carbon footprint by 30-40% in England and 10-30% in France. So to conclude all of my work, although the temperature difference between air and seawater is not significant in the channel, there are still locations with the potential for SWACs, cooling and heating. I already mentioned that even we saw those cooling capacity factors, SWAC cooling capacity factors, they are less than 5%, but we still need to remember that there are facilities which needs cooling non-stop at much lower temperatures than 20 degrees. And the SWAC potential is definitely for hub facilities, research facilities, and data centers. Then SWAC heating abilities has a substantial potential for heating buildings in the channel, as we could see. The carbon dioxide emission can be significantly reduced by installing SWACs in the channel area. And there is still a lot of work to do. So I already showed you the framework, and there are still like those 3 last boxes, probably the most important. So we have all of the things which can go into it. Now we need to calculate the cost of those areas for the SWAC. So this will be the next step. And also I already identified components for optimization, but all of them will have to be optimized, and this will be done within the next couple of weeks. Okay, that's it from me. Thank you very much.
Thank you, Ola. Okay. So does someone have a question in the chat? I believe we have actually Ola. Don't worry, we had some questions this morning, and as a lot of the actual people here were there this morning, I think a lot of the questions has already been answered. Okay, we have Martin Brown who said, have you undertaken any investment appraisal for a promising site?
Sarah, can you?
Have you undertaken any investment appraisal for a promising site?
No, so this is the next step. So I think this will be very exciting. So now we have all of the information. We identify those areas. We also have the SWAC capacity factors for cooling and heating. This will go all into the last stage of the modeling, and hopefully the next time I'm presenting, I will have the maps which will just show the costing of the SWAC for the whole channel.
Okay.